Welcome to the deep dive. Today we're taking a slightly different approach. We've got this collection of practice questions for the 6V0-22.25 certification, which is all about the AVI load balancer. And our mission isn't really about passing the test itself, it's about mining these questions for the real gold, the practical foundational knowledge you need for setting up, securing, and really tuning a high-performance load balancing setup.
Okay, let's unpack this. It's interesting because the exam format, 90-minute 65 questions, 70% to pass it, kind of forces you to know the crucial operational stuff cold. We're going to pull those key insights out, starting right at the beginning with the architecture, resilience.
Absolutely, because if your load balancing controllers go down, well, managing the whole data plane just stops, right? So redundancy is key. But what's the bare minimum, the absolute floor for controller nodes in an HA cluster?
Yeah, the solid recommendation, the minimum number of controller nodes you need for a resilient cluster is three nodes.
Okay, hang on. 3. Usually, for redundancy, I think pairs. Active, passive, active, active. 2 seems standard. Why the insistence on 3 here?
It really comes down to ensuring consensus and critically preventing what's called a split brain scenario.
Split brain, okay.
Yeah, think about it. With 2 nodes, if the link between them breaks, what happens? They can't tell if the other one crashed or if the network's just down. So both might try to take over.
So they both become active independently.
Exactly. And you get 2 conflicting states. It's a mess. With 3, you need a majority vote, a quorum. If one node fails, the other 2 can still talk, agree on the state, and keep things running consistently.
Got it. So quorum needs at least 3 to function if one fails. That makes sense. It's about consistency over just simple backup.
Precisely. It's a design choice for data integrity.
All right, so that's the controllers, the sort of management brain. What about the service engines, the SEs? The actual workhorses handling traffic? Automation's a big deal there, I hear.
Huge deal. And how much automation you get hinges on one key setting during setup. The SE placement access mode, there are 2 main ones. No access and write access.
Okay, no access versus write access. What's the practical difference for someone managing this day-to-day? Like, what do you actually experience?
Well, the core difference is really about operational overhead and automation. If you go with write access, you're basically giving the AVI controller permission to automatically create, manage, and even delete the service engine VMs or cloud instances for you.
On whatever platform we're using, like vSphere, AWS.
Exactly. Full lifecycle automation for the SEs. It handles scaling, deployment, everything.
Okay, that sounds convenient, but giving a controller permission to spin up and delete VMs across my environment, that sounds like a pretty big security permission jump. Is that the catch?
That is the trade-off. Write access needs elevated privileges in your vCenter, your cloud account, whatever. Higher trust, bigger security consideration.
Right. And the alternative, no access.
With no access, the controller can only, look at the inventory. It can see what's there, but it can't make changes. So you, the administrator, have to manually create the SE VMs, configure them, manage their lifecycle.
So more manual work, less automation, but tighter security control because the controller's permissions are limited.
You got it. It's a fundamental choice. How much automation do you want versus how much control or maybe how much trust are you willing to extend to the controller?
Makes sense. It's an architectural decision right at the start. Okay, so let's say we've made that choice. Our SEs are deployed. Now we're talking performance, dealing with heavy traffic. Here's where it gets really interesting. Apparently, a simple config toggle can make a big difference to SE performance.
Oh, definitely. If you're pushing serious volume, thousands, tens of thousands of connections a second, and latency is critical, you absolutely need to look at real-time logging.
Real-time logging sounds useful for troubleshooting, so good or bad for performance?
It's fantastic for visibility, no doubt, but it's a performance hog. Generally, to really squeeze performance out of an SE in high-throughput situations, the recommendation is often to consider disabling real-time logging.
Really? Why does logging hit performance so hard?
Because it's constantly grabbing super detailed data for every single transaction, every request, every response. That eats up CPU cycles, it uses memory, and importantly, it hammers the disk I/O on the service engine itself.
Yeah, the disk I/O.
Yeah, exactly where you need resources for pushing packets. So disabling it frees up those SE resources to just focus on forwarding traffic. It's a trade-off again. Lose that immediate granular log visibility, but gain raw speed.
So maybe enable it only when you're actively debugging a specific problem virtual service.
That's a very common strategy. Use it surgically, not globally, if performance is paramount.
Practical tip. Visibility costs performance. Treat accordingly. Okay, let's pivot from performance to security, specifically encryption. SSL/TLS setups can get complicated, fast certificates, protocols, which ciphers are allowed. Where does Avi centralize all of that configuration?
That's handled by a specific object, the SSL/TLS profile. Think of that like a template or maybe a policy for all things encryption related to a virtual service. It defines which server certificate to present, which TLS versions are okay like, only TLS 1.2 and 1.3 perhaps, and precisely which cipher suites are permitted.
So instead of setting allowed ciphers on every single application or virtual service.
You define it once in the profile, and then you just apply that profile to multiple virtual services. It standardizes your security posture and makes management way easier.
That modularity sounds essential for larger deployments. Okay, sticking with customization, Avi's powerful partly because you can go beyond the standard click and configure stuff, right? What's the feature that lets you write custom code to mess with traffic?
You're talking about data scripts. That's where the real programmability comes in. Their main job is letting you customize application behavior by basically intercepting traffic requests or responses and modifying them.
Intercepting and modifying. Like, give me an example. What kind of modification?
Oh, all sorts. You could rewrite HTTP headers on the fly, maybe inspect a request, see if it's coming from a mobile device based on the user agent, and then redirect it to a different pool of servers optimized for mobile.
Okay, so it's like writing little traffic rules with actual logic, if-then condition.
Exactly. Way beyond what standard Layer 4, Layer 7 profiles can do. You can apply really specific custom logic that might be unique to your application. It's like having a programmable traffic cop you script yourself.
Very cool. But all that power doesn't help if the backend server isn't even responding. Let's talk basic health checks. Usually we use HTTP or TCP monitors, but what if you have a server that's super minimal, like really locked down? What's the fallback?
Right. If you've got a backend server that's so basic, or maybe firewall rules are so tight that it literally only responds to a ping, an ICMP echo request, then you must use a ping health monitor.
Right.
It just sends that simple ICMP echo to check if the IP is reachable. If you try to use a TCP monitor, which needs a port open, or an HTTP monitor, which needs a web server responding, on a server that only does ICMP.
The monitor will fail even if the server is technically up and running.
Correct. It'll always report the server as down. You have to match the monitor type to what the server can actually respond to. Ping is the lowest common denominator.
Match the monitor to the capability. Got it. Now, let's connect monitoring to security signals. The system gives virtual services a health score. If an admin sees that score drop and the reason explicitly says security issues, what part of the system is flagging that?
If the health degradation reason is specifically security issues, the prime suspect, the feature most likely reporting that, is the web application firewall, the WAF.
Ah, the WF. So it's not just blocking bad stuff, it's also feeding into the overall health picture.
Absolutely. The WAF app is constantly inspecting the traffic for known attack patterns, SQL injection, cross-site scripting, things like that. When it sees enough suspicious activity, based on its rules,
It flags it.
yes, it doesn't just block potentially malicious requests, it also signals that the application is effectively under attack, which directly lowers the virtual service's health score. It tells the admin, hey, this service isn't just slow, it's potentially compromised or being targeted.
That's a key insight for troubleshooting WAF activity impacts the health score directly. Okay, brings us to how the system tells admins about problems generally. Alerts. Let's clarify the pieces here. What's the difference between defining the problem and defining the notification?
Good distinction. Configuring an alert itself is purely about defining the what. It's setting the conditions that trigger something.
Like CPU utilization hitting 90% or maybe a specific error message appearing in logs?
Exactly. The alert defines the trigger. If this specific condition occurs, that's its sole purpose.
Okay, so the alert is the trigger condition. Where do you define the then do this part, like send an email or create a ticket?
Right. The action sending that email, firing off an SNMP trap, calling a webhook, whatever that's configured separately, usually as an alert action or notification profile that you link to the alert rule.
So you could have one alert condition like pull server down, trigger multiple different actions, maybe an email and a PagerDuty notification.
Precisely. That separation makes it flexible. You define the problem once and then decide how you want to be notified about it, maybe differently based on severity or time of day.
Efficient. Okay, shifting to how traffic gets spread around. We know basic round robin just cycles through servers. But what's the algorithm for being smarter for sending new connections to the server that's, least busy right now?
That dynamic approach is the least connections algorithm. It's state aware. Before sending a new connection, it actually checks how many active connections each server in the pool currently has and directs the new one to the server with the smallest number.
Ah, so it's looking at real-time load, not just rotating.
Exactly. This is way better, especially if your application has connections that last for varying amounts of time. If one server gets stuck with a few really long, heavy sessions, these connections will naturally start favoring the other, less loaded servers.
Instead of just piling more connections onto the busy one like round robin might.
Right. It leads to much better, more even resource utilization across your back-end pool based on actual current workload.
Real-time load awareness. Makes total sense. Okay, last piece, the audit trail. When something's a config change, a system event, someone log in, where does an admin go in the UI to find that definitive history?
For that comprehensive system-wide view of everything that's transpired, config changes, user login, system health events, critical errors, the canonical place is the Operations System Logs page. That's your main audit log, your historical record for the entire AVI control plane.
Operations system logs. Imagine you had a really specific, maybe security-related requirement that standard profiles just can't handle. Let's say you needed to check the source IP of an incoming connection against some external proprietary threat intelligence list before you even let the request hit your servers. How could you use a data script to implement that kind of custom preemptive check? What kind of logic could you build there that goes way beyond standard load balancing? Something to mull over. That wraps up our deep dive for today. Thanks for joining us, and we'll catch you on the next one.